Hi everyone, we're part of LegalSumAI. Our project deals with generating robust legal summaries from case documents with large language models. The key research question is seeing if we can prompt an LLM to produce accurate legal summaries of court case documents, all in natural language.
Well, for the motivation for our project, we know that legal battles are a common challenge for many Americans, with approximately 56% of US households encountering legal issues annually. These tasks are not only frequent, but also high risk, often involving lengthy documents that are difficult for the general public to comprehend. Large language models, or LLMs, offer a promising solution to assist in legal cases due to their ability to process and analyze large volumes of text quickly and accurately. However, LLMs are highly susceptible to hallucinations, which is especially harmful in a high risk domain like the legal realm. To mitigate this, we developed a pipeline that prevents LLM hallucinations through optimized prompting techniques such as chain of density and pre-processing methods like creating structured fact sheets. We'll be using the multi-lex dataset that provides expert-authored summaries for various U.S. civil cases. Given various legal documents like dockets and opinions, expert-level summaries are provided at three different granularity levels of tiny, short, and long. The paper also generates summaries via an LLM, which are compared to these expert-authored gold summaries.
So LegalSumAI essentially proposes a two-step pipeline. Instead of directly prompting the LLM for natural language summary from the source documents, we first generate CSV fact sheets to represent the information in a more structured manner. So given the legal document for a case, a CSV is generated to provide more information on the issue, rule, application, and conclusion, as well as the parties involved and other logistical case information. The first four categories that I mentioned are known as IRAC, and it is a common technique that lawyers and law students use to effectively summarize information. Following this same technique, a CSV is created for every source document for a case, and then a master CSV is created that combines all these different source documents for a case. Then, once we have this master CSV, natural language summaries are created from these worksheets. For each summary size of short, tiny, and long, each is prompted 4 times with chain of density prompting. And then for each prompt, a summary of the corresponding size is generated 5 times, and then the best summary is selected based on cosine similarity. Then the best summary from the last prompt or the deepest level of the chain of density pipeline is then selected to evaluate via Rouge and BERT score metrics as LegalSumAI does.
Our results have high BERT scores, indicating that the generated summaries capture the essence and semantic meaning of the source document well. Our lower Rouge scores just indicate fewer direct matches in terms of words or phrases. Overall, a high BERT score and low Rouge scores indicates that the generated text is contextually and semantically accurate, while diverging in wording from the source text. This can be explained because we wish to generate summaries for the general public, where the wording should be more simple, and thus we don't end up mimicking the exact verbiage from the expert summary. Thus, our results validate that our summaries retain the original meaning. Our BERT scores are much higher than Multi-LegalSum's BERT scores across all granularities, as shown in the table, with BERT scores improving as much as 207% and on average improving around 157% for all categories, and indicating a much more accurate summary. Right here, we see the outputs of the tiny, short, and long best summaries. We selected the best generated summary by comparing it to the ground truth values, and they are outputted here. We can see that they do a fairly good job of summarizing a case.
Overall, our pipeline produces accurate case summaries efficiently. It is efficient in that it automates the process as opposed to traditional expert-generated summaries. Excuse me. It is accurate since it prevents LLM hallucinations by having a multi-step process, including fact sheet generation, chain of density prompting, and multiple runs. Overall, our pipeline provides accurate case summaries for the general public, ensuring legal information is available and accessible for all. In the future, we wish to expand this project by extending testing to more than just the civil law cases that were provided in the dataset. We wish to further our prompting techniques, as well as extend to other related tasks and creating even domain-specific applications for various law firms. So now we'll provide a live demo of our project. Thank you.
So now let's see how this model does at finding a summary from a completely unseen source text. So going to Google, we can type in legal cases PDF and see what we get from that search. So we have a few options. Maybe let's pick the second one here. And then we can just copy all of the text in here and just paste it into our window. And just to verify that we have everything, we can just print out our case in our notebook and just make sure. And so it looks like we do have everything. And it also looks like our case is pretty long, as expected for a legal case. So if we go to the original document, we see that the case is about 70 pages long, which is pretty standard for a lot of cases out there. And so that's kind of why summarizing is important. But we also know that 70 pages is a little bit too long for the context window of our model that we're using, which is GPT 3.5 Turbo. And so to fix this, we kind of need to break the text into several chunks, run our fact sheet generation protocol in each one of these chunks, and then prompt another model to consolidate all of this information into one fact sheet. And so we see the result of that right here. We see several categories with descriptions under each. And so the model has kind of processed all the information, digested it, and is now ready to summarize. And so when summarizing, we can input a number of words for the model to use as a guideline as to how long the summary should be. And so when we input 25 words, we're kind of looking for about a sentence. And so looking at our output here, we see that it has pretty accurately summarized the court case above. Just skimming, we saw that it was talking about a case between 303 Creative and some other party involving free speech. And so we see that it has kind of hit that. It has told us what happened and kind of why it's important. And so now looking at a 100-word summary, we expect to see a little bit more detail and a little bit more emphasis on why the case is important and how it applies. And so in our generated text here, we see that. We see the parties involved, we see what happened, and we see why it's important and what it means for legal precedent. And so our model does in fact work on unseen source text.